power. In the circuit diagram above, the ratio of the electric power dissipated in the 6 ohms and 3 ohms resistors respectively is. So here we are to calculate the power dissipation in 6 ohms and 3 ohms and then find their ratio. That's ratio of that of 6 ohms to 3 ohms. So now electric power P can be given as what? Electric current times what? The voltage. Electric current times the voltage. Or it can be given as what? Current. If you split voltage is current times resistance. So this will be current squared times R. So this is the formula we're going to use to do this. So how do we now calculate the power in each of these resistors? First, for us to be able to calculate the power, we have to know the current, because the current is what we don't know here. We have to know what? The current. So this is how it's going to go. And how do we calculate the current in this? How do we calculate the current that goes through the 6 ohms or the current that goes through the 3 ohms? Can make this one I1 and then this one I2. Okay, but before we do that, let's first calculate the total current I coming from the cell. Now equivalent voltage will be equals to what? The total current, or equivalent current times what? Equivalent resistance. So if we make current there the subject, current there will be what? Equivalent voltage over equivalent resistance. So how do we get our equivalent resistance? Since there are two resistors connected in parallel, the equivalent resistance can be given as what? 6 times 3 divided by 6 plus 3. That's R1 times R2 divided by R1 plus R2. If you still want to go 1 over R, that equals to 1 over 6 plus 1 over 3, it will still arrive at the same point. But this pattern I'm doing is only for when there are two resistors in parallel. If it's more than 2, you use the conventional method or the conventional formula. So we proceed. So this will be equals to 6 times 3 is 18 over 6 plus that 9. 9 will divide 18 2 times. So the equivalent resistance equals to what? 2 ohms. So therefore our total current or equivalent current, their total voltage from the cell there is 12 divided by equivalent resistance 2. Total current becomes what? 6 amps. So now we have gotten our current. I'll shift this up a bit. So now we've gotten our current. Now this current will be splitted into 2 based on the value of the resistor. And you know, sorry about that. This total current that is coming from here will be splitted into 2. When it will be splitted into 2. Will be splitted. One will go to the 6 ohm, one will go to the 3 ohms, based on the value of their resistances. You understand? So we are going to find out the current that goes into each of these resistors. So for the 6 ohm resistor, the current that goes through it, current through the 6 ohm resistor, will be what? The voltage. And since this is a parallel connection, they will share the two resistors will share the same voltage, which is this 12 that they are seeing. So for the 6 ohm, the current passing through the 6 ohm would be the voltage through that resistor over the value of that resistor, which is 6. And the voltage there is what? 12 divided by 6, which equals to what? 2 amps. So the current through the 6 ohm resistor is 2 amps. And the current I2, or you say current I3, through the 3 ohms resistor will be the voltage. The voltage across this parallel connection is 12. That the voltage across this resistor is 12 divided by value of the resistance 3. That divided will give us what? 4. Sorry. That will give us 4. 3 divided 12, 4 amps. So if you see, 2 amps plus 4 amps will give us what? 6 amps, which is the total current from the cell. So now we've gotten the current through each resistor. So we can now calculate the power through each resistor. Permit me to clean some of this. We can now calculate the power through each resistor. So now the power P through the 6 ohm resistor will be what? IV, or current through 6 ohm resistor, and the current through 6 ohm resistor as we calculated was 2 amps. So that would be 2 times 12. 2 times 12 will give us what? 24 watts. And then power through the 3 ohm resistor P3 will be current through the 3 ohm resistor times the voltage across it. The voltage across it is 12. So the current across the 3 ohm resistor was 4 amps. So that will be 4 times what? 12. And 4 times 12 is 48. 48 watts. So now we can see the power in the 6 ohm is 24 watts. That in the 3 ohms is 48 watts. So the question was, find the ratio of the 6 ohm to 3 ohm, the power. That's the ratio of their power. So ratio of their power will be ratio of P6 to what? P3, which equals to P6 is 24 watts, is to P3, that is 48 watts. So we now reduce this to the lowest term possible. 24 cancel itself 1, and cancel 48 2 times. So the ratio of their power, P6 to P3, will be what? 1 is to 2. So the ratio of the power dissipation is what? 1 is to 2. Thank you.